Okay, this is cross product. So if we had a vector A and a vector B, and the angle in between them was theta, then vector C would be equal to A cross B. And the magnitude of C is equal to the magnitude of A times the magnitude of B times the sine of theta. Alright, so C has a direction that is perpendicular to the plane containing A and B, such that C is specified by the right-hand rule. So for instance, in this problem, using the right-hand rule, we'd get A cross with B, and C would be pointing up, just like it is. Okay. So let's talk about the laws of operation for a cross product. A cross B is equal to negative B cross A. So, A cross B gives you C in the upward direction, but if we did B cross A, it's negative C, which is why in the laws of operation it would have to be negative B cross A would give you the same result, positive C. There's the associative law. Which is a scalar A times A cross B is equal to the scalar A times the vector A cross B, which is also equal to A cross the scalar A times B, or A cross B times the scalar A. Alright, and then we have the distributive law. Which is A cross B plus D is equal to A cross B plus A cross D. Alright, so now let's look at our unit vectors. So we've got I, J, K. So oops, that's not an I cross J. So if we had I cross J, curl your fingers towards, your thumb would be pointing up, so that'd be positive K. Now we're going to do all of these. So we got I cross K, all the different variations. I cross I, J cross K, J cross I, J cross J, K cross I, K cross J, and K cross K. Okay, so let's start looking at these. So if we had I cross K, you'd point your fingers in the direction of I, curl towards K, and my thumb would be pointing in the negative J direction. And now for this one, I cross I, the angle between I is 0. Okay, and the magnitude of the cross product is AB sine theta. So sine of 0 is 0. So that would mean that there is no cross product for I cross I. It's 0. Okay. So let's look. J cross K, so you point your fingers in the direction of J, curl towards K, and my thumb would be pointing in the direction of I. Oops, excuse me. So this would be I. Okay, now we've got J cross I. So if we point our fingers in the direction of J, curl towards I, our thumb is into the page, so that's negative K. J cross J is the same thing as I cross I. The angle's 0, so the sign of 0 is 0. Okay, K cross I. Point your fingers in the direction of K, curl towards I, and my thumb is pointing in the direction of J. It's positive J. Okay, put your fingers in the direction of K, curl towards J, and we get negative I. And K cross K is going to be 0. Okay, so say we wanted to do A cross B, where A is equal to AXI plus AYJ plus AZK. Cross that with BXI plus BYJ plus BZK. Okay, and now we've got to distribute these out. So we would have, this would be equal to AX times BX. Since those are just scalars, they can multiply. But then the vectors would be I cross I. Okay, and then we would add AX BY I cross J plus AX BZ K I cross K plus AY BX J cross I plus AY BY J cross J, and then we'd have AY BZ J cross K plus AZ BX K cross I plus AZ BY K cross J plus AZ BZ K cross K. Okay, so we just found the answers to all of these cross products up here. So I cross I is 0, so this is 0. I cross J is K, so this is going to be K. I cross K is negative J. J cross I is negative K. J cross J is 0. J cross K is I. K cross I is J. K cross J is negative I. K cross K is 0. So if we were to combine like terms, we would get that A cross B is equal to, so let's combine all the I terms first. So we'd get AY BZ minus AZ BY. All of this is multiplied by I. We do minus all the J products, so we would get AX BZ. This is a positive J, but we've minus, so it's going to be minus AZ BX multiplied by J, and then all the K, plus our positive K, AX BY minus AYBX multiplied by K. So we put it into this form with this negative because this is the determinant of the matrix. So let's look at that. So we've got A cross B. And if we were to put this in a matrix form, we'd put our X, Y, and Z components, unit vectors at the top, and then we'd put our X, Y, and Z components of A, and the same thing with X. I'm sorry, the same thing with B. And now what we just found is the determinant of the matrix. So let's look at that. So the first thing you do in a determinant is, I'm going to write this simply so that you don't have to write that a bunch of times. But we've got I, J, K, and then we've got the A's and the B's. So I guess I will write it out. So the first thing you do in a matrix is you cover up the I column and row, and then you multiply like this, and then you subtract like this. So the first component would be AY BZ minus AZ BY. You multiply that whole thing by I, the component that you crossed out. And then in a determinant, one of the easiest ways to make a mistake is to forget that the second thing, the middle component, whatever it is, must be minus. So then we'd have the same thing. So for the middle component, cross out its row and column, and we do the same thing. AXBZ minus AZBX. So AXBZ minus AZBX multiplied by J. And then for our K component, okay, cross it out, the row and column of K, and then it's AXBY minus AYBX. So plus AXBY minus AYBX multiplied by K. Now if we look, that's exactly what we got when we multiplied the whole thing out. We had AYBZ minus AZBY multiplied by I, AXBZ minus AZBX multiplied by J, plus AXBY minus AYBX multiplied by K. So it's the determinant of the matrix. So let's do a quick example with numbers. So let's say our A is equal to 2I plus 3J minus 4K. And our B is equal to 1I minus 5J plus 3K. And we want to find C, where C is equal to A cross B. So C is going to be equal to I, J, K. Then the magnitude of AX 2, magnitude of AY 3, magnitude of AZ negative 4. Same thing with B, 1, negative 5, 3. Okay, so the first thing we do is the I component. So you cross out this column and this row such that we would have 3 times 3 minus negative 4 times negative 5. That's all multiplied by I. Then we do minus the j component, so cross out this column, and we would get 2 times 3 minus 4 times 1. So 2 times 3 minus a negative 4 times 1 times j. And then add the last one for k, so it would be 2 times negative 5 minus 3 times 1. So 2 times negative 5 minus 3 times 1, all multiplied by k, such that c would be equal to 9 minus positive 20, which would be negative 11, I, minus 6 plus 4, so that would be minus 10j. And then for 13, we'd get negative 10 minus 3, which is equal to negative 13k. Okay, and so now we found C, which is the cross product for A cross B. And that's how you do cross products.